Welcome to XGSLab version 10. In this video, we will share some of the latest advancements. As always, great steps have been taken, and we are proud to present our newest module, SHIELD. Protecting critical infrastructure from lightning events is a growing concern in many regions of the world. Evaluating the performance of lightning protection systems for your critical infrastructure is now easier with SHIELD. SHIELD provides you a full 3D application for modeling lightning protection systems and structures that you protect. The SHIELD module allows you to enter either IEEE or IEC as a reference standard. From there, you can obviously import or draft your geometric information, the three-dimensional system that you want to evaluate. Here we have the blue conductors representing our lightning protection system, and these green conductors representing the structures to be protected. Then we can determine if we're going to evaluate our system using the rolling sphere method or the Erickson method. Hitting this calculate icon, you can enter in information like the BIL in order to calculate your striking distance. This is used in order to evaluate your system's performance. We can see a top-down view where we can see some of our system is not protected, and a three-dimensional view illustrates this from a different perspective. Again, red conductors representing non-protected objects. And we have our XGL view as well to display these results in a little more flexibility. A new XGS feature is the XGLCAD view. Here you can visualize your system in 3 dimensions. You can also incorporate 3-dimensional structures, such as a sphere. Here we're adding a red sphere that will be approximately have a radius of 50 meters. And when we apply this, you can see a large sphere enters into our model. The NETS module has allowed you to analyze multi-phase mesh networks for steady state, unbalanced power flow, and detailed fault information for current into the earth and alternative paths. The hybrid cell feature allows you to analyze the effects of AC interference on cables, pipelines, and other objects in shared corridors. Here, in our hybrid cell called shared corridor, we have a transmission line, and adjacent to it is a buried pipeline. When we go down, we can see that the conductor information for the transmission line is entered in the table below, as well as the conductor information or the pipeline's information. Looking at the results, we can evaluate the current that's going through our transmission line phase conductors. Here we see approximately 500 amps of steady state current is flowing on the phase in port 1. When we go to port 5, which represents our pipeline, we can switch to the potential view and see that approximately 3 volts is induced on that pipeline. Many features have been added to the soil modeling capabilities of XGSLab. Here, we'll show the multi-zone soil modeling capability to place landmarks. Traditionally, when you added a new soil resistivity zone, we would enter the coordinate system into the table. Now, using this place landmark icon, we'll be able to create a new zone and place that coordinate or that new zone into our drawing. Many additional features have been included in this version of XGSLab. Contact us today for questions or to request a demo.